Hello friends, in this video we are going to study the power handling capacity or wattage of series and parallel combination of resistors. So what is power handling capacity of resistor? It is the maximum power that can be handled by the resistor without breaking down, and we know that we can find that using the basic formula that power is equal to V square by R, or it is equal to I square into R. So this is the basic formula. Now let us consider the series combination first. So for that I'll consider initially the 1 kilo ohm resistor, and which is connected across the voltage of 100 volt. So here I'm having the 1 kilo ohm resistor which is connected across a supply of DC supply of 100 volt. Instead of DC supply we can also consider the AC supply, because the behavior of resistor is same for DC as well as AC. It is not frequency dependent. So this resistance value is 1 kilo ohm. Now here if I calculate the power that is appearing across this resistor, it is nothing but V square by R. It is equal to 100 square divided by 1 kilo ohm. So that is why this power is equal to 100 square means 10,000 divided by 1k, it is 10 watt. So here I need to use a resistor of 1 kilo ohm, but the power handling capacity should be greater than 10 watt. So if I'm not having this 10 watt resistor of 1 kilo ohm with me, what I can do? Because 10 watt resistor is not generally available. It is not ordinary resistor. In our lab, in our day-to-day life, we are having the resistors of quarter watt, half watt, 1 watt, maximum 2 watt. So this 10 watt resistor, you may not have it. So what you can do? There is one solution. See, instead of using this 1 kilo ohm resistor, I can use there two resistors in series, and these resistors of, say, they are of 500 ohm. So each of them is having the resistance value is 500 ohm. So 500 ohm connected in series with 500 ohm, the equivalent resistance is now R1 plus R2, that is 500 plus 500 is 1k, and the total voltage applies 100 volt. So that is why here now if you calculate the power which is appearing across, say, this resistor R1, one of the resistor, so it will be nothing but here there will be division of voltage. So this 50 volt 100 volt will be divided into two parts. As these resistors are equal, here the voltage will be 50 volt, and here again it will be 50 volt. So 50 plus 50, it will be 100 volt. So now if I calculate the power handling capacity, that is V square by R. So here V square means 50 square, that is 50 into 50 divided by 500. So if I calculate this, I'll get 2500 divided by 500. So you'll get the power which is appearing across each resistor, it is 5 watt. So what is the conclusion? If I use, instead of using 1 kilo ohm resistor, if I use the two resistors of 500 ohm, right, their wattage which is required for each resistor, it is half. Again, if I use, say, the 10 resistors in series, so what will happen? We can see, if I use the 10 resistor, first, second, third, up to dash 10 resistors, there are 10 resistors, and each of them is having value, equal value, such that their equivalent is the 1 kilo ohm. So this each resistor will be of 100 ohm, 100 ohm, 100 ohm. So there are such 10 resistors, right? And the total voltage which is applied is 100 volt. Now in this case, if I calculate the power which is appearing across each of this 100 ohm resistor, so this power is equal to V1 square divided by R1, right? So here, what is the voltage which is appearing across each of this 100 ohm resistor? It will be 1/10 of total voltage, so it will be 10 volt. So 10 volt square divided by resistance value is 100. So that is why this power, it will be equal to 10 square is 100 divided by 100 is 1 watt. So that is why the power wattage of resistor which is required and the series combination of each resistor is 1 watt. So what is the conclusion? Instead of using, see, 1 kilo ohm resistor of 10 watt, I can use the series combination of multiple resistors having equal value, and in that case what will happen? The wattage requirement of each resistor will be less. Even you can use the different resistors having different values, but their equivalent will be, say, the required value of resistors, say 1 kilo ohm. So I can use here say 400 ohm, 400 ohm and 200 ohm. So in each case the power handling capacity required by each resistor, it will be less than this first case. So this is the advantage. If you connect the small resistors in series, it increases the power handling capacity of that circuit. Now let us consider the parallel combination. So in parallel combination, again consider the same example here. If you are having the 1 kilo ohm resistor which is connected across the supply of 100 volt. So here the power which will be required, it is the power requirement, handling capacity of this resistor is 10 watt. Now instead of using this 1 kilo ohm resistor, I can connect two resistors in parallel such that their equivalent resistance is 1 kilo ohm. So in this case I have to connect two resistors each of value 2 kilo ohm in parallel, and across this parallel combination I'll apply the voltage 100 volt. So this circuit, its equivalent is same as that of this first circuit. Now if I consider, say this resistor is R1, say this resistor is R2, now the power handling capacity which is required for R1, it will be V square divided by R1. Why? Because voltage in parallel combination is same. So that is why it is 100 square divided by R1 is 2K. Hence power requirement, it will be 100 multiplied by 100 divided by 2000, and hence it is nothing but 10,000 divided by 2000, it is 5 watt. So here the power which is required, it is now half, right? Just here we have to select the resistors which are greater than the original resistor. Again, if I connect, say, the 10 resistors, right, in parallel, so that their equivalent will become, say, 1 kilo ohm. So there I'll require 10 kilo ohm resistor. Each of the resistor will be of 10 kilo ohm, 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 10 kilo ohm. Such 10 resistor will be in parallel. Their equivalent will be 1 kilo ohm, and in that the each resistor, the power handling or power dissipation across each resistor, it will be 1 watt. So if you connect the resistors in parallel so that the equivalent resistance is equal to the original resistance, then the power handling capacity of that circuit increases. So this is the advantage. If you are not having the high wattage resistor with you, what you can do? You can do the series or parallel combination as per your need, and you can increase the power handling capacity of the circuit. In that case, each of the series combination resistor or parallel combination resistor, its power handling or wattage will be less, and that is easily available with us. Thank you.